All right, so now it's time for the clustering roadshow. We're actually going to go through and use a lot of different techniques to build clusters using the same data set, and then we'll contrast them towards the end. So this is just different ways where we can build these three clusters. So where we have clusters 0, 1, and 2, just hours of the day that are very different in different ways. In class, we'll go into the nuance of how these methods actually work. So first, let's do a k-means cluster. Is the k-means approach. Basically, we're saying these are the clusters that we would identify if we were using the k-means clustering. You can see some slight differences. So in the spectral clustering, the borders between classes are not quite as sharp. That is, you have some variation along the boundaries, whereas in k-means, you have very, very straight boundaries. And again, we'll talk more about why that is the case, and why you would choose k-means over spectral later in the course. The next one we're going to look at is a mean shift algorithm. All right, and here's the outcome of the mean shift. You can see mean shift is very different when contrasted to k-means. In the case of mean shift, we are identifying a much larger groups 1 and 2, or 0 and 1, the purple and blue, and a much smaller group 3, the yellow group. And you can see the yellow group, right, that there's very little kind of, there's a relatively straight boundary for the yellow group as contrasted to the blue and purple group, and also a relatively straight boundary between the blue and purple groups. So you can see, again, there's just, fundamental differences in the types of clusters you would create. Different hours would be defined as being similar to each other in very different ways. Next, we'll go and implement an agglomerative clustering model. All right, and here's agglomerative clustering. So you can see the breakdown again is very different in terms of the clusters that it's going to be defining. We still have 3 different clusters in this particular case because we're defining 3 clusters is what we're asking for. So these are the kind of traditional clusters. And again, we're going to talk about the nuances of this in class. The next 2 models that we're going to look at are different approaches to clustering where the goal is to identify outliers. So if you're trying to find basically unusual things in your data. And the first one we're going to look at is dbScan. So here's dbScan, and you can see dbScan has effectively gone through and it's identified all of these points in the middle have neighbors. These points on the outside do not. And so these points on the outskirts of our data are defined as outliers, or defined as unusual data points in dbScan. Optics is another approach attempting to do the same thing. In this particular implementation, optics is going to be a little bit more sensitive. And so here's optics, and you can just compare optics to dbScan here, where for this particular configuration of optics, optics is picking up slightly more outliers or slightly more unusual data points than we see in the case of dbScan. The next one we're going to look at is something called Birch. So the Birch model, this is another clustering approach, and this is most closely related to classification trees. This is effectively trying to build something very similar to a classification tree that maximizes the differences across different clusters of data. Here we go. So this is Birch. Again, we have 3 classes, and you can again see slightly different cases. And in class, we'll talk about, again, more of why these are different and why you would select one or the other. But this is the implementation for Birch. And then the final thing we're going to do in this video is talk a little bit about how we can quantitatively compare these different cases, right? So we've kind of flown through how you can create technically and implement these, but we haven't talked at all about really how you would pick one over the other. In class, we're going to talk about the theory, but here we can talk about the quantitative approach. So we're actually going to use something called the Davies-Bouldin score. So Davies-Bouldin is a good choice if you care about separation the human eye would detect. And there we go. So this is the scores that we received, and you can see in this particular case that the scores approaching 0, right? So spectral clustering in this case has the smallest score. So overall, in this particular case, we would want to choose spectral clustering because spectral clustering is the option where the classes are the most clearly defined. In the next model, we'll talk a little bit about how we can actually use this information for an analysis.